Action of NP and transistor. We are going to discuss about the working and the action of NP and transistor. In that case, this is N-type semiconductor material. This is also N-type semiconductor material, and this is a P-type semiconductor material. Now, we know the name of the terminal. This terminal is emitter. This is our base, and this is collector. So when we are going to discuss about this terminal, then we know that emitter emits the charge carrier through itself, and collector collects the charge carrier. Now, the thickness of this base region will be of 0.1 mm, or 0.01 mm. That's when this region is too much thick. Now, in absence of biasing, that's when we have not applied any potential at the any in, the emitter base circuit, in absence of biasing, the emitter base circuit, the current flowing through the collector base would be very small. That's mean collector बेस के थ्रू फ्लो करने वाला करंट जो होगा बहुत ही स्मॉल होगा, जो कि माइक्रो एम्पियर का होगा. इट मीन्स हमने कोई बाइसिंग अप्लाई नहीं की, इधर से कोई करंट फ्लो नहीं कर रही है, बट इधर जो है एक करंट फ्लो करेगी जो कि माइक्रो एम्पियर में होगी, बिकॉज यहाँ पे कोई पोटेंशियल हमने अभी अप्लाई नहीं किया है. व्हेन द इमीटर जंक्शन इज बाइस्ड इन द फॉरवर्ड डायरेक्शन, अब हमने क्या किया, इसको फॉरवर्ड डायरेक्शन में बाइस कर दिया. इट मीन्स अब यहाँ पे हम बाइसिंग करते हैं तो दिस इज एन टाइप, दिस इज पी टाइप. सो फॉर मेकिंग फॉरवर्ड बाइस वी विल अप्लाई नेगेटिव ऑन द एन टाइप and positive on the p type. The current is slightly less than the current in the forward bias region. Now, this thing should be in reverse bias, so that's why n is connected with positive and p will be connected with negative terminal of the battery. This is positive terminal, this is negative, this is positive terminal, this is negative terminal. ठीक है, this is forward bias applied across the N and P type emitter and base, and this is reverse bias applied across collector and base. In this case we will see that a current will flow from here and from here, and here the current will come out from the circuit. This is current IE, this is current IB, base current, and this current is taken as IC. Now, after applying negative potential, the electron will move towards P side and it will cross the P side. That's when base region. In forward bias, in forward bias, electron from emitter will move towards collector. Few electron will recombine with holes of base, that's p type. Some electron which is moving from emitter to collector will recombine in this region. It means that we can draw a diagram. Here is the motion of the electron in which the few of electron are recombining with this. Less than 5%. We can say that less than 5% electron will recombine in the base region. So there will be a current inside the base. And in case of collector, this electron will be attracted. So current, this is the motion of electron. Electron of the collector region will move in this side, and majority charge carrier hole, minority charge carrier will move towards the collector terminal, while the minority charge carrier hole will move opposite. So we can draw the current this is current majority current of emitter charge carriers. IC, and this is current from this region due to minority charge carrier. In the collector region, we are seeing that there are two type of charge carrier participating to flow the current. One is or majority charge carrier of electron motion in this direction, and the holes motion in this direction. So that's why here is the current due to majority charge carrier IC, and this is the ICO. Normally for these three terminals we are applying Kirchhoff's current law. In that case we can write IE is equal to IC plus IB. It means that current through the emitter is equal to current through collector plus का current through the base. Here the amount of base current is too much small. Now this is the current flowing due to minority charge carrier. This is also known as reverse leakage current. Reverse leakage current. reverse leakage current. What is reverse leakage current? Small current due to minority charge carrier. Minority charge carrier of collector to base junction is known as reverse leakage current. It is represented by ICO. So net current IC, that's mean net current IC is equal to ICO plus का I of majority. That's mean current through the majority charge carrier plus का current due to minority charge carrier in the collector region contributes the total current. So we can write this equation in another form, that will be IE is equal to IB plus ICO plus का I of majority. Emitter current through the NPN transistor is equal to base current plus leakage reverse leakage current plus का current due to majority charge carrier. Similarly, when we are considering PNP transistor, in that case hole from this side will move to collector region, then current will be in this direction. Now one thing most important, the symbolic representation of NPN transistor is in this manner. In which we have drawn the arrow towards the emitter. This is emitter, this is base, this is collector, and this is your base. Here in NPN the arrow was towards the emitter from the base. See here, the current at the emitting terminal is outside, so that's why this arrow is representing the direction of current through the transistor. Okay, now similar case we will consider for PNP transistor. So let's discuss for the PNP transistor. Now action of PNP transistor. In case of PNP transistor, there will be P-type semiconductor material, in the side region. P-type semiconductor material, this is also P-type, this is our N-type. Now charge carrier here will be electron, and in this region it will be hole. and few electron will be also here as a majority charge carrier. This is a metal contact provided to the transistor, which will uniformly distribute the potential applied across its terminal. Let's apply the potential across their terminals. See, this is emitter, this is base, and this terminal is collector terminal. So emitter base for a operating region should be in forward bias, so that's why P should be connected to positive terminal of the battery and this should be connected to negative terminal. And collector base junction should be reverse bias, so that's why this P should be connected with the negative and this N should be connected to the positive. This region, in this manner I have applied the voltage across each terminal. Now the positive terminal will emit the current, so that's why here current will be inside. This is our current IE and it will collect current, and also this is IC and this is IB. See, this positive will repel the hole, then hole will start motion in this direction and it will move towards collector, and few holes, less than 5% hole, will recombine in this region. So a small current will drop inside the base and all current will passes through the collector. So we can say that only less than 5% charge carrier emitted from the emitter will recombine in base region, and then these hole will be attracted towards the collector terminal. Then a current due to majority charge carrier will flow in this direction, and see, this hole will be repelled, then hole will start motion towards base, so that's why a small amount of current due to hole ICO will flow. So net current IC is equal to ICO reverse leakage current plus का current due to majority. Now from these terminals we are applying Kirchhoff current law, then IE is equal to IC plus IB, where IC is equal to majority current due to majority charge carriers plus का reverse leakage current. So that's why IE is equal to IB plus का ICO plus I of majority. Here no need to discuss about reverse leakage current because we know that a small amount of current. will flow due to minority charge carrier present inside the collector region, which is known as reverse leakage current. So current in this region will be due to majority, that will be maximum, and few holes less than 5% will recombine in the base region, and less and greater than 95% will move towards the collector. And here majority charge carrier will contribute that current, and also minority charge carrier ICO will also contribute the flow of current. Now we are going to discuss about DC current gain in configurations of transistor. Now we are going to discuss about configuration first of all. First of all, we are going to discuss about configuration. Configuration of bipolar junction transistor. See, this is our BJT. I have taken NPN BJT. This is base, this is emitter, and this is collector. And it can be drawn like this also, in this manner. Emitter, base, collector, and also it will be in such manner also. Emitter, base, and this is collector. We need two terminals to connect with the battery, one with positive and the other with negative. So here we can use these two as input terminal and these two terminal as output terminal. Also these two terminals are also used as input terminal, and these two terminal can be used as output terminal. And in third one, base and collector can be used as input terminal, and emitter and collector can be used as output terminal. So we have three different type of configuration. Three different types of configuration. This is your first, second, and third. So how can we name this configuration? So first, see, base and emitter is being used as input terminal, and collector and emitter is used as a output terminal. So emitter is common between input and output. So that's why this configuration is known as common emitter configuration. The first configuration is common emitter configuration. Now, second one. Here base is common between input and output. So it is known as common base configuration, and here collector is common between input and output, so that's why third configuration is known as common collector configuration. Okay, so we will discuss about these different configuration in our next video. Thanks.